So the title of this talk is The Accepted Math Mistakes in Einstein's Relativity. And a general note, by the term light speed, it generally meant to mean in vacuum in the context of inertial frames without the influence on it by the fields such as gravity. So it's usually just meant in the context of special relativity. So this is the paper that starts all the problems, Einstein's first paper on special relativity. There was numerous problems and it's hard to go through them all, there's so many. So I've asked ChatGPT, which is my favourite AI, to give the accepted math mistakes in Einstein relativity. I have to keep asking it any more after it gives a list of them to get all of them, else ChatGPT just gives a partial list. So my question to ChatGPT was, do you have a complete comprehensive list of the math mistakes in Einstein relativity with the corrections made? And ChatGPT had to think for 14 seconds. And the short answer was, there is no single accepted complete comprehensive list of math mistakes in Einstein's relativity because most so-called mistakes fall into a few classes: historical slips, incomplete early calculations, coordinate stroke convention confusions, or later refinements. Not a long list of fatal algebraic errors. Below I give a compact, careful, organized starter catalogue you can use as the basis for a full reference document. It lists the main historical stroke technical items people point to, what kind of issue each is, such as algebraic slip or convention stroke interpretation, approximation or outdated stroke early stage derivation, and the standard correction or modern viewpoint. If you want, I can expand any item into a fully referenced paper with primary sources, corrections, modern treatments, or build a living canvas document you can edit. So I'm only given an introduction to the math mistakes within Einstein's relativity and the corrections that have been made to it. So this is the catalogue of mistakes that the AI has given me, and I'm not going to read it all because it takes a long time to read it all. So number one type of mistake is the early straight partial predictions, which he made for such things as the light deflection. And so the takeaway from that was an early limited model, and it was later corrected by the full theory. So he made this calculation mistake in 1911, and his full theory, which was supposed to be general relativity, came out in 1915, with which that mistake gets corrected. Number two is the enough field equations. They made a mistake in those. And between special relativity and general relativity, special relativity 1905 and general relativity of 1915, he was trying to work out extending special relativity, and in between that period he came up with what was now called the enough theory, and in that theory he made a lot of mistakes, and he had to abandon that for when he later formed general relativity. So the takeaway from that is it's supposed to be, from the mainstream point of view, normal scientific development. You have a provisional theory, which is the enough theory, and it's supposed to be corrected later by the full theory, which is general relativity. So number three is sign stroke factor slips in early gravitational work in 1916 to 1918, and he made algebraic stroke interpretive mistakes in early derivations of wave energy. So the takeaway from that was early confusion resolved by consistent perturbation theory and better boundary conditions. Number 4 was coordinate singularities versus physical singularities. He got confused by different types of singularities. And so the takeaway from that is many paradoxes are coordinate artifacts, and you must distinguish coordinates from invariant geometry. So number 5 is the use of the energy momentum pseudo tensor for gravitational energy. So you got confused with that. And so the correction stroke modern view is you use global quasi-local notions and accept that local gravitational energy density is not a covariant tensor. And the takeaway from that is not an algebraic error, but a deep feature of diffeomorphisms and variance. And number 6 is clock synchronization, stroke one-way speed of light subtlety. And the type problem there is its convention stroke interpretation issue with the synchronization choice. So the takeaway from that is it's a conceptual subtlety, not a mathematical error. At least that is what the mainstream wants to believe, usually. And so number 7 is early approximation stroke omitted boundary conditions in wave and radiation calculations. And so it's technical approximations that we find later. And so it's more of a technical refinement than a fundamental inconsistency. Number 8 is confusions about global topology and coordinate patches. And the takeaway from that is differential geometric care is required. And number 9 is Newtonian stroke relativistic limit mistakes in derivations. So the takeaway from that is use systematic expansion schemes to avoid order errors. Well, number 10 is misstatements due to sloppy notation or coordinate choices in original papers. Einstein was very sloppy in writing out equations. And the correction is that modern textbooks standardize conventions and clean up derivations. And the takeaway is, well, I suppose when you read Einstein, you've got to keep an eye to conventions. Number 11, interpretational claims presented as empirical facts, e.g. metaphysical conclusions from formalism. So the type of problem there is philosophical stroke interpretation rather than a mathematical error. And the takeaway from that is what's mathematical from what's philosophical is essential, knowing the difference between the two. Number 12 is specific historic algebra slips that were corrected quickly. So those are the categories we just dealt with, and now we're getting on to the list of the mistakes. Number 1 is the light deflection mistake, and that was made in 1911. And next one is the mistake with the Antonov equations. That's the theory between special relativity and general relativity that had mistakes in it. That was in 1913. And in 1916 there was gravitational waves paper, and that had mistakes in it. And number 4 was misuse of energy momentum pseudo tensor. And number 5 is the coordinate singularity at the Schwarzschild solution. So AI then goes on to give extra ones. Number 6 is the early Porphyrian precession calculation made before 1915, and there's a mistake made there. Number 7 is the rotating coordinate systems, and a mistake was made in that. Number 8 is the first gravitational wave paper, 1916, and it had the wrong wave types. And number 9 is the Hall argument. Einstein thought general covariance was impossible because of the Hall argument, where coordinate freedom seems to undermine determinism. And that was a mathematical interpretation mistake. The takeaway is not an algebra error, but a logical mistake in handling coordinate freedom. Number 10 was the cosmological constant. 1 minute he has it, and next minute he gets rid of it, and then later people wanted to bring it back again. Number 11 was the gravitational redshift derivations. So additional accepted slips are number 15, 1905, mass energy paper, where he got the E equals mc squared, he made a mistake in that. And 16 is he made a mistake in this first gravitational wave paper. And number 17, the Einstein Rosen bridge paper, he made a mistake in that. While 18, he made a mistake in spinning dust solutions. So what's not counted is his cosmological constant blunder. It's philosophical stroke physical, not a math error. And the Hall argument is a logical misstep, not an algebraic mistake. Interpretations of simultaneity, ether, etc. are conceptual, not mathematical. So they're trying to count some mistakes as not being mathematical. I was given a chronological list of all these mistakes by AI, and it only had 17, so I queried that and it gave me 18. And here's the corrected list. So this is the corrected list of all 18 mistakes. 1905, incomplete derivation of E equals mc squared. 1911, mistakenly light deflection calculation. Number 3, 1911, gravitational redshift. That was some of the mistake. And then 1913, enough equations had mistakes in it. And then 1913, this calculation for mercury precession was wrong. 1913 to 1914, he had energy momentum conservation mistake. And then in 1914, he had the Hall argument misstep. And 1915, enough abandoned, that's his enough theory is abandoned, and there was a correction to his equations. 1916, the gravitational waves, sign stroke factor errors, and so forth. 1916 to 1918, pseudotensor misinterpreted as tensor. 1917, static universe unstable. Eddington was supposed to have corrected that. 1917, the cosmological term had a sign convention inconsistencies, and so 1918, rotating frame mishandling. And 1919, horizon misinterpreted as physics singularity. 1932, Einstein de Sitter oversimplified equations and neglected pressure. 1935, the Einstein-Rosen bridge is flawed coordinate treatment. 1935 to 1936, he claimed gravitational waves don't exist, and he had an error there. And 1935 to 36, he also had particles dust models with division by zero mistakes. So he was making mistakes all the way through his mathematics. And this is the list of 18 that AI has come up with for his mathematical mistakes, which are accepted by the mainstream. So what AI says, that's about 18 distinct historically recognised math/technical mistakes. After that, everything else, historians' list is interpretive problems with the ether, simultaneity, philosophy, and so forth. So thank you very much. That's the end of this short talk. I sort of rushed through it rather than read everything. So you've got 18 mathematical mistakes made by Einstein, and the problem with that, you probably could start counting them in different ways, but these are the accepted mistakes that Einstein made. Next, I'll be wanting to look at the mistakes that people claim that he made in his maths, which are not accepted by the mainstream. So thank you.